Welcome to trigonometric functions of any angle. Our objective overall is to evaluate trig functions of any angle by using reference angles as well as being able to find measures of sides. Right? We're going to have many little units in little mini lessons within this larger unit. And we're going to start off with special right triangles. It'll be essential for us to be able to work with two very specific types of right triangles. So certain triangles possess special properties that allow us to use shortcut formulas in arriving at information about their measures. These formulas let us arrive at the answer very quickly. Now I'm going to show how the formula is derived. You do not need to take notes on how the formula is derived, but there'll be on the next page, in the following pages, there'll be formulas that I'll need you to write down, as well as some sample problems. So on your notes, it looks like a table. Right? So you're going to fill in the table once we learn the special formula here. All right, so here we have there are two different triangles that have some special properties we're going to work with. The first one is the 45, 45, 90 special triangle. All right, so if it has two congruent angles, it has two congruent sides. The sides opposite those angles are congruent. So this is an isosceles right triangle. And it has two congruent sides. And we're just going to call those two congruent sides legs. Legs squared plus legs squared. Of course, opposite the right angle is the hypotenuse. All right, so we're going to work with no numbers at all, just leg and hypotenuse, and see how this formula comes about. So that you can see, so if I prove it in a very general case here with no numbers, you'll know it's true all the time when we have numbers. All right, so leg squared plus leg squared is hypotenuse squared. I could add leg squared plus leg squared together, and that would give me 2 leg squared. Right? But we're not looking to have things squared, right? We need to take, for solving, right? We want to take the square root of both sides. All right, so we're going to take the square root. I'm going to take the square root of 2 legs squared. I'm going to take the square root of hypotenuse squared. All right, well, let's look at hypotenuse squared first. Of course, square and square root will cancel. So the square root of hypotenuse squared is just hypotenuse. Right, so this is a product, 2 times leg squared. Right? And so I could rewrite that. Right? We have leg squared is one part of the product, and then the square root of 2 is the other part of the product. Now one of those is a perfect square. Of course, leg squared is a perfect square. Square root of leg squared is leg. Square root of 2 is not a perfect square, and we can't simplify that at all. It's a prime number, and it has no buddies to free it from radical prison. So leg square root of 2 equals hypotenuse. And now you have discovered or have learned, I guess, I did all the work. You didn't discover it, I did discover it. You've learned now one of the special formulas. There's a relationship always when we have an isosceles or a 45, 45, 90 right triangle. And it doesn't matter what the numbers are, because you can see I can use the word leg and hypotenuse and it'll be true. And that is, the hypotenuse is the square root of 2 times the leg. Right? And that is going to make that very, very easy to find missing measures. And all we need is to know is a 45, 45, 90 right triangle and one side in this type of right triangle. All right, so 45, 45, 90 special right formulas. All right, so now you're going to write some things into your notes. Right? So it has a spot for the leg, has a spot for finding the hypotenuse. All right, so H stands for hypotenuse, L stands for legs. Both legs are the exact same measure. All right, so in the box it says finding the hypotenuse. All right, the hypotenuse is equal to the leg times the square root of 2. Right? Finding a leg. The leg is equal to the hypotenuse divided by the square root of 2. Or you may prefer writing it like the in the box there, as opposed to writing it with a division symbol. Now you do need to rationalize the denominator. You do not need to write in the steps here to rationalize the denominator unless this is something you're a little unsure of. If you're unsure of how to rationalize a denominator, then absolutely put this in your notes, and if you don't have enough space, put a little sticky note or put it up in the top or something. I think there's some extra space in the top. Right? So we have hypotenuse divided by 2. Right? Hypotenuse divided by the square root of 2 is our leg. Right? And so now we don't, and here I'll show you just using that other formula, right? So if we have hypotenuse equals leg times the square root of 2, and we divide both sides by the square root of 2, we have hypotenuse divided by square root of 2 equals leg. Right? Well, we can't leave the square root of 2 there, so multiply the square root of 2 over the square root of 2. That will make this, the denominator, a rational number, because the square root of 2, just in case you weren't sure, square root of 2 times the square root of 2 equals the square root of 4, which is 2. And now we have a square root of 2 in the numerator, which is perfectly fine. So the leg is equal to, because we can't say divided by square root of 2, hypotenuse times the square root of 2 divided by 2. It's exactly the same thing. We just multiply both sides by a form of 1. Both sides. The numerator and denominator by a form of 1. Square root of 2 over square root of 2 is a form of 1. Right? That's equal to 1. And by doing so, we rationalize that denominator. Okay? So we're always going to rationalize our denominators here. That's all there is to working with the 45, 45, 90. If you know the leg, multiply by the square root of 2 and you get the hypotenuse. If you know the hypotenuse, divide by the square root of 2, but don't forget to rationalize if needed. Right? If you don't end up with a radical in the denominator, then you don't have to worry about it. Okay? All right, so let's take a look at solving a couple problems. One of these is in your notes. I don't know which one, and I'm not sure I have the notes over on the board, on the table there, so I'm working without the notes. Maybe I'll put the microphone down and run really quickly and see if it's over there. And actually, maybe I'll leave, we're going to solve these problems here. Maybe I'll leave that up for you for a minute. I'll be right back. Okay, you write that down. I do have a set of notes. All right, so under finding the hypotenuse, you're just going to write hypotenuse equals leg times the square root of 2. Under finding a leg, right, you're going to either write in this right here, right, in the box. That'd probably be best. Right, if you can write small enough so that you can have all the steps there, and it'll help you if you know the hypotenuse and you're looking for the leg. Right? Or you can put in the box. The other one is you can write the stuff that's in the box there if you're very certain on how to rationalize a denominator. Right? That's just showing you how to simplify it. All right, so let's solve two problems. I got two for you in your notes. The first one is not the first one I'm going to do, right? So you can just watch along with me, and then you'll solve the second one. So we're going to find the hypotenuse. This one is so easy. By the way, this other leg is 22 as well. And the hypotenuse is equal to the leg times the square root of 2, which means the hypotenuse is equal to 22 square roots of 2. Pretty easy. Right? This one is in your notes, the second one. Right, this leg here is also 5 square roots of 3, right, because it's isosceles. The hypotenuse, remember, and you should write the whole thing in, is equal to leg times the square root of 2, which means the hypotenuse is equal to 5 square roots of 3 times the square root of 2. When you're multiplying radical, you multiply radical and radical. You do not multiply radical by a number. It's radical to radical. It actually is 3 things multiplied together. It's a 5, it's a square root of 3, and it's a square root of 2. Square root of 3 and square root of 2 becomes square root of 6. And your answer for the hypotenuse is 5 square roots of 6. And there we go. That's all there is to it. Now let's go the other way. Let's find the leg if we have the hypotenuse. First one is in your notes. All right, so again, I'm just going to write hypotenuse equals leg times square root of 2. I always just use that one rather than trying to remember that leg is hypotenuse divided by square root of 2, because then I just have one formula. And actually, that's why I put that particular formula, the original formula, since it changes the page. The original formula here, hypotenuse equals, this one here, equals leg times the square root of 2 in the top of the notes there, is because I just use that one formula. I remember one formula, and then I just simplify it. And so whatever I'm looking for, right, I just isolate the other one. I got one, I isolate the one I don't have. That's so I can solve. All right, so here I have hypotenuse equals leg times the square root of 2. That's what we're looking for the leg. All right, so I'm just going to call this x, I guess. I could call it L, but it kind of looks like a 1. All right, so we don't know either leg. They're both the same. All right, so 17 is the hypotenuse, is x times the square root of 2. We're going to solve for x, so we've got to divide by the square root of 2. But we can't leave the square root of 2 in the denominator. We have to rationalize it. So we're going to have 17 times the square root of 2. Times 17 over the square root of 2 times square root of 2 over square root of 2. Right? I figure I better show you all the steps. All right, so we're just multiplying by square root of 2 over square root of 2. It's just 1, right? Anything over itself is 1, but this will this will make our denominator a rational number, which is what we're looking to do. All right, so then here, of course, this is just x, because that was canceled. And now we can simplify. So this would be 17 square roots of 2 over the square root of 4. Square root of 4 is 2. If you are perfectly comfortable with going from square root of 2 times square root of 2 is just going to be 2, because you know it's the square root of 4, you can leave that step out and just go right to that last step. And that is x. And that's the one in your notes. Okay? And if you have questions, you can ask me in class. And then let's look at the last one here. All right? So here we're solving for x. It's actually a pretty easy one. So hypotenuse is leg times the square root of 2. Square root of 6 is, and we'll just call x times the square root of 2. We'll divide both sides by the square root of 2. This just becomes x. And this is just, you can make, so the quotient of radicals is the same as the radical of a quotient. So this is actually the same as the square root of 6 divided by 2. It's exactly the same. Right? You can combine products and quotients when you're with radicals. And so now this is just the square root of 3 is equal to x. And that's it. We're done. And that's all I'm going to show you with the special right triangle for the 45, 45, 90. We'll look at the second one. This is your whiteboard practice. Right? You can either turn in your work, or just if you want to keep it in your notebook and just type in your answers, I'll take either one. All right? Make sure you reduce if possible. All right? And if you, by the way, if you're getting answers incorrect, it would help me if I could then see your work, so then I could know what it is you're doing wrong, and then I could help you fix it. Right? If all I see is your answer, by the way, if you're getting it correct all the time, I'm going to kind of assume your work is correct. But if you're making mistakes and all I have are your answers, and you don't let me see, don't have your work available, it's going to be hard for me to help you. Right? So make sure you solve them. Actually solve them out. But then you can just type in your answers, or if you just want to turn in your paper, that's okay too. Right? You'll get the if you don't want to type in the answers, you just want to give me the paper, that's fine too. All right, so here let's look at the second one. The second special triangle is a 30, 60, 90. Now what I have here is not a 30, 60, 90. It's an equilateral triangle. This one is equilateral. Okay. And we have, this is an altitude, right? So this right here is an altitude. In an isosceles triangle, and an equilateral triangle is a type of isosceles triangle. It's just an isosceles triangle with 3 congruent sides. The definition of isosceles triangle is to have at least 2 congruent sides. All right, so And so this would be, these two are of course congruent. And in an isosceles triangle, the altitude is going to split the base into two congruent segments. The altitude is always perpendicular to the base. Not only will the altitude in an isosceles triangle split the base into two congruent segments, it splits the angle too into two congruent angles. So that means that each of these smaller angles is 30 degrees. Okay? So we're just going to work with one of them because we're interested in the 30, 60, 90. But we're going to we use this equilateral so that we could have everything be in one variable. Okay? So we have one leg, the altitude, that we don't really know that much about. However, we have another leg that we know a lot about, right? So this leg here, I guess I'll just put an X on it. That leg right there, opposite the 30-degree angle, right? Since I said that the altitude divides that into two congruent parts, we know this is going to be 1/2 of A. This is the side we don't know anything about, right? I don't want to use A, even though it's the altitude. Let's use H, which is another, sometimes people call the altitude the height, right? So let's call that H. Now, I guess I shouldn't use H, I just realized it. Because the hypotenuse is also called H, I don't want to confuse you. Let's not call it H. Take it back. Take it back. Let's just call it Y. Call it generic old Y. You don't even get a good name. Just Y. All right, so we don't know anything about that side, except I told you that it was perpendicular to the base. And it splits the angle in half, and it splits the sides in half, but you don't really know anything about its measure. All right, so we have one side, which is half of A. We have another side, which is the hypotenuse, which is A. And then the third side we're just going to call Y. Right? So now let's use Pythagorean theorem here, and let's see if we can figure out, if we can solve here for Y, right? Because everything else has got the same letter. So we're going to solve things in terms of A's. Right? So we have 1/2 A squared plus the other leg, which gets to be called Y squared, is equal to A squared. A squared is the hypotenuse. Right? This was the hypotenuse. And this is one leg, and this is the other leg. Leg 2. Right, so these legs aren't going to be congruent like the other ones. So I can't just call them leg and combine them. All right, so now let's square. All right, so this would be 1/4 A squared plus Y squared equals A squared. I've got A's on both sides, so let's combine the A's together. Right? So we're going to subtract 1/4 A squared from both sides. So now I have Y squared is equal to 1 minus 1/4. Well, 1 is the same as 4/4. This is going to be 3/4 A squared. Now, we weren't solving for Y squared, we were solving for Y. So let's take the square root of both sides. Oh, and by the way, because the measures of triangles are lengths, we are not taking a positive and negative. When we're solving quadratics, remember we took positive and negative square roots. Because this has to be positive, you can't have negative measurement. You can't be negative 5 feet tall. We only take the positive. So I don't even bother to write down the negative. But remember, if we were just solving a radical, we were just solving something quadratic, we would have two solutions. All right, so we have the square root of Y squared equals the square root of 3/4 A squared. All right, let's put the perfect squares together. But let's split that product up a little bit. Well, of course, we know the square root of Y squared is just Y. All right, so I'm going to rewrite this as 1/4, yeah, I'll put that 3 last, times 3, and this is all under a radical, times A squared. Now you might be saying, how did you make 3/4 equal to 1/4 times 3? Well, what is 1/4 times 3 but 3/4? Right? So 1/4 times 3 is the same as 3/4. I'm going to move things around a little bit. Y equals, so I'm going to put the y/4 and the a squared together. And I can split, so the square root of a product is the same as the product of the square roots. You can't do this with adding and subtracting, but you can with multiplying and dividing. All right, so 1/4 times a squared times the square root of 3. If we couldn't simplify radicals. Times the square root of 3 is the same as 3/4 a squared. It's exactly the same thing. I've just rewritten it. Now, one of these is a perfect square, the 1/4 a squared. All right, so the square root of 1/4 a squared is just 1/2 a. And then we have the square root of 3. And now you've learned the relationship between we call this y here the long leg. The reason it's called the long leg is because it's opposite the larger angle of the two, not including the right angle. So 60 is a larger angle than 30 is. Right? So the side opposite the larger angle is going to be larger, and it's one of the legs of the triangle. Right? We have a short leg and a long leg. So the long leg is equal to, now this 1/2 a, that's the short leg. Right? So this one here is the long leg, and that's the short leg. And I guess I could have called it that from the beginning. But y here is the long leg, and the long leg is equal to the short leg times the square root of 3. The other relationship is pretty easy to figure out, and that's the relationship between the short leg and the hypotenuse. Well, how much bigger is a than half of a? The hypotenuse is equal to 2 times the short leg. If you multiply 1/2 a times 2, you get a. And those are our two relationships. I only focus on the short leg. I'll show you the relationships between the long leg and the short leg, and the long leg and the hypotenuse, and the hypotenuse and the short leg, and so forth. But if you only remember 2 things, you can solve all the problems. Right? As long as you remember the relationship between the long leg and the short leg, and the hypotenuse and the short leg, you can always find the short leg, and then you can find the other one. And that's what I always do, by the way. The less remembering, the better. But I will put all of them up here, which is this, has all of them. All right, so find the short leg, find the long leg, find the hypotenuse. All right, so we're going to write them all in just in case, so that you have those. I use one more than the other, and that is I use the short leg. I always go with the short leg whenever possible. So for instance, if I know the hypotenuse and I'm looking for the long leg, I use the hypotenuse to find the short leg, and then I just do short leg times the square root of 3. Right? And I think I went over that, the formula, right? So back here we actually proved it, right? Because we were using generic letters. And if it's true for generic letters, it's true all the time. That's why you can't use numbers in a proof. So the long leg is the short leg times the square root of 3. All right, so now in the box that says finding the hypotenuse, which mine is at the bottom and yours is at the top, but that's okay. Find the hypotenuse in the blanks there. You can write in that the hypotenuse is equal to the short leg times 2. So this goes in the 3rd box in your notes. All right, hypotenuse is short leg times 2. Now, you can write in the other one as well. I would, but I don't like that one quite as much. And actually, let's write it rationalized. So the hypotenuse is equal to 2 times the long leg divided by the square root of 3. Let's write that a little nicer there. So, and I usually, actually, instead of putting short leg times 2, I usually put 2 short. But whichever way is perfectly fine. However, when you're using the long leg there, let's write it like this next to that black asterisk, because I think that makes a little bit more sense, because it's all together as opposed to this kind of long thing, and we don't usually put we don't really use that division symbol like that when we're solving. We use the fraction bar, and notice we have to rationalize. So instead of writing 2 times long leg with that division sign, just write this one instead, and that is it's 2 times the long leg times the square root of 3 divided by 3. So we rationalized, there was a square root of 3 in the denominator, and we just multiplied numerator and denominator by the square root of 3, just like we did on the other page. Okay. So our longer leg is just the length, our hypotenuse is just twice as long as the short leg. That's the most important one to remember, because if you don't remember how to find it from the long leg, you can always just find the short leg and then use that one. All right, so now looking to the next box in your notes, finding the short leg, it's opposite the 30-degree angle. So in your notes, the short leg is opposite 30-degree angle. The short leg is equal to the hypotenuse divided by 2. I prefer to write the black asterisk one, and I think you probably should too. I can type one way, I can write another way. So I would write the green handwriting in there, in that box. Short equals hypotenuse divided by 2. It equals the long leg divided by the square root of 3. But remember, we have to rationalize. So when we rationalize, right, because it would be, actually I'll put it in green so I stay consistent with the color there. All right, so long leg divided by square root of 3, we'd multiply by square root of 3 over square root of 3. Right? So that now would become square root of 9 in the denominator, or 3. Right? So that's why we have a 3. Right? So short leg is the long leg times the square root of 3 divided by 3. And then the last box there, the long leg is opposite the 60-degree angle. The long leg is equal to the short leg times the square root of 3. That's all there is to it. I put it, the red writing is exactly identical to the black writing there where I wrote it out. Except for I made the long leg look a little nicer as an equation. Long leg is hypotenuse times the square root of 3 divided by 2. Right? Because we would take the short leg, so this half a hypotenuse here is the same as the short leg, and we multiply it by the square root of 3. So if you know the hypotenuse, you can just take half of it and multiply by the square root of 3, and you got the long leg. So hopefully these notes are all filled in. Now let's look at 3 problems on the next page, and that's going to end this podcast and this page of notes for you. All right, so we want to find the value of the variable. All right, so, and I'm going to label it each time. This one is, the first problem is not in your notes. All of the others are. Okay? So this is the long leg. This is the short leg. And this is the hypotenuse. I always find the short leg first if I don't know the short leg. All right, so short equals long divided by the square root of 3. Right, and then we can rationalize it if we need to. So our long is 8 square roots of 3. And so short is x here. So x is equal to 8 square roots of 3 divided by square root of 3. Well, here's one time where I shouldn't even bother to rationalize it or write square root of 3 times square root of 3 over 3. It's when there's already a radical there, because that'll just cancel out. So x is 8. The hypotenuse, let's put it up here. Hypotenuse is equal to 2 times the short. So that means y is equal to 2 times 8. Y is 16. There we have our 2 missing sides. That was all there is to it. Next one is in your notes. Right? So we have, this is the short. This is long. This is opposite 60 and this is hypotenuse. All right, I'm going to find short first. All right, so number short equals long divided by the square root of 3. Or you can write times the square root of 3 over 3, and because in this case it's going to kind of work out that way. So our short here is the x is 8 divided by the square root of 3, and I'm going to have to multiply by the square root of 3 over the square root of 3, all right, to rationalize it. So now this is going to become 8 square roots of 3, and this would be square root of 9, which is 3. To find our hypotenuse, the hypotenuse is equal to 2 times the short leg. So y is 2 times 8 square roots of 3 over 3. You just multiply the two numbers are both in the numerator. 2 times 8 is 16. So 16 square roots of 3 over 3 is twice as big as 8 square roots of 3 over 3. Y is 16 square roots of 3 over 3. All right, so that one's in your notes. And I'll kind of box those. I usually like to keep my podcast to 30 minutes, no more. This one's over 30, but I don't have too much left. All right, so here, looks like we do the hypotenuse all the time. Except for, actually, we do the long leg twice. This one's the hypotenuse. So I'm going to find the short leg first because that's easiest. And then the long. The short is half the hypotenuse. That means x is half of 15. You could write it as 7.5 if you want. I'm just going to leave it as 15 halves. The long is the short. Oops, I can't put it. I can't fit it there. Times the square root of 3. So long equals short times square root of 3. So that means the long y is equal to 15 halves times the square root of 3. And that's it. We're done with that one. Put that one in your notes. It's pretty easy if you have the hypotenuse. Just go find the short leg and then multiply whatever the short leg is times the square root of 3. This is the easiest of all. We have the short leg. That's the easy one. This is short. We want long. It doesn't matter what you find first. So here, this is long. This is hypotenuse. So your long is equal to the short times the square root of 3. So x is equal to 2 times the square root of 3 times the square root of 3. Square root of 3 times square root of 3 is the square root of 9, which is 3. And so x is equal to 6. Hope that isn't too crowded. This one's in your notes. It's the last one. And then y is the hypotenuse. And the hypotenuse, that's good enough. Hypotenuse equals 2 times the short. So that means y is equal to 2 times 2 square roots of 3, which means y is 4 square roots of 3. And that's all there is to it. Then we're done with these problems, and that's it for special right triangles. Right, I'm going to have you solve these. Actually, you know what? Instead of making these two, put them on the Nearpod, I'm going to make these as part of your group work, your partner work. All right, so these won't be on the Nearpod, just the tape, just watching me. And these problems you'll do with a partner. All right, so rather than to put them in, they won't be there. All right, and I'll give them to you as soon as you finish a series of videos. Of course, actually, if you have a partner and you want to work on that set after you've watched the video, I can be fine with that. And then you're going to, so this isn't going to be a closing. It'll be the closing to my Nearpod. This is going to be a fill-in. You type in the missing words on Nearpod. You'll see this. All right, so thanks for watching. That's the end of this tape. Bye for now.